Welcome to Let's Talk ASPM. My name is Mark Lambert.
And I'm Rohan Parak.
And we're here to do part 3 of our mini-series about application security and the tools that you need to make sure your application is securely developed. So we started talking about code, and that's often where application security is focused, or starts, should I say. We talked about static application security testing. We talked about software composition analysis. We then transitioned to getting that code into the cloud, because of course that's where most applications are deployed these days. We talked about IAC, container security. We talked about cloud security posture management, yet another acronym, CSPM. Now we're going to talk about more acronyms and abbreviations. We're going to talk about dynamic application security testing, penetration testing, red teaming, bug bounties, and we'll see where we go from there. All right, so let's start with dynamic application security testing, or DAST. Where does that fit in the ecosystem? When do you do it? How does it help inform your subsequent steps from a test validation?
In many ways, it goes back to how do we traditionally test software, right? We test software by kind of practicing it, by kind of exercising the software itself. And dynamic application security testing, the roots come from that. Historically, that was all done manually, but eventually, the technologies evolved where you could use automation to do a lot of those testings. Automation in a way where it could identify the most common vulnerabilities in those applications, OWASP top 10 to name the most common list. Dynamic application security testing essentially makes sure that a lot of business logic flaws in your application can also be discovered, which otherwise it's difficult to look at the code and say that this is a business logic flaw. What is a business logic flaw? Take an example of your application, which is an online shopping application. It has a shopping cart. Can I buy something which is worth $1,000 without paying anything? It's a business logic flaw. Session-related vulnerabilities. So there are a lot of class of vulnerabilities which will be in the first-party code, within your own code, that the most effective way of identifying those is through dynamic application security testing tools.
So we've done kind of like analyzing the structure of the code, the dependencies with the kind of like the static application testing, looking at vulnerabilities that are in our containers. Now we're looking for those logical business flaws, right? So how can I actually make the application behave incorrectly? And so DAST will help inform what parts of the application I want to do. What's the difference between penetration testing or pen testing and something like a red teaming? Because I hear different terminology, right? We hear pen testing, red teaming, even bug bounty programs. What are these three different classes and how do they fit in?
Right. So penetration testing is essentially a more human-augmented version of DAST. DAST over the years evolved into a more automated scanning-based approach. But pen testing would kind of be able to do things that a scanner would not do. It would be able to identify issues that a scanner would not be able to do. Which means that there is deeper analysis of those applications, deeper exercising of those applications, and a more deliberate attempt to kind of break into applications based on the skill and experience these pen testers would have eventually gained. In some ways, the tooling can be more of a progression. Most common open source DAST tools are like OWASP, ZAP, and Burp Suite are also used by pen testers, but more as a feeder to their work that they are doing, which is where they are going to kind of get more deep into the applications to find these logical vulnerabilities. Now, pen testing is in a term that is used in in a historical sense. A more modern approach to that same outcome is red teaming. Red teaming is with the goal of essentially thinking more from an attacker's perspective, and not only looking at the target itself, but the supporting targets as well. So it's not only going to focus on the application, but things that are going to kind of support application, technical support of that application or the users of that application, the human link, and the environmental link as well. So all of those factors are combined into a red teaming exercise. All of these exercises, we talk about penetration testing or red teaming, these are all done within the scope of the organization, more from an inside-out scope. The outside in approach of this is essentially what translates into bug bounty programs. So the ability to essentially crowdsource the analysis, the whole process of getting vulnerabilities for your application, especially when they're publicly facing applications. Platforms like HackerOne or Bugcrowd would allow you to get anybody in the world, essentially, a big community of security research, test your applications and report security flaws, essentially adding a massive scale of crowdsourcing to you and at the same time giving an incentive to those security researchers as well to do that good work that they keep doing.
Okay. So really giving a platform for those ethical hackers to be able to do, provide you insight without having to do bad things. Yeah.
And this continues into the runtime aspect of it as well, right? And I think you have some more analysis on that as well, because runtime concept, we have spoken about that in the last podcast about how runtime is important from a cloud and code to cloud kind of aspect, but from finding issues in first party code, what's has been the norm in the security testing space?
Yeah, so this is where another acronym comes in: interactive application security testing. So if you think about DAST is, we're looking at a black box. We're trying to figure out what are the vulnerabilities? How can I break it by going from the outside? Just kind of like looking at a black box. Software composition analysis, static code analysis is really more white box, right? I can see what's inside, and I'm trying to identify the issues. What IAST does is it nicely bridges the two. So the advantage of DAST is it's real. It's got a runtime context, but I don't know where within the code base it is. IAST will run at runtime when you're exercising the application, and it'll basically run kind of like static application security testing rules to identify behavior that's going outside of the norms that you would expect. So it gives a level of kind of like making it more like a gray box, so I can kind of see inside what's going on. But what's really also interesting is how can I take this data from these different techniques and start to correlate them together. So in the cloud, when we talked about obviously runtime in code analysis, we talked about reachability analysis, but we also talked about how we can link from cloud, like our CSPM, Cloud Security Posture Management, misconfiguration, to the IAC, Infrastructure as Code misconfiguration. With the AI correlation that we're doing here at ArmorCode, we can also start to correlate runtime data from like penetration testing and DAST all the way back to SAST as well. And I think that's one of the areas where you've got to try to figure out how to bring these things together so you can get to a point of remediation.
Yeah, and I think interactive testing is that what's called, right? I think the whole correlation part just lights up everything for you, right? And at the end of the day, with the goal of how do you expedite the remediation, because that's your goal every time. How do you kind of reduce the mean time to remediation in your environment?
Yeah, so we're, as an industry, I mean, the purpose of this mini-series is really to help educate everybody about all the different types of scanners that are in place, giving you lots of data. But at the end of the day, you have to bring all of that data together so you can prioritize and mobilize your teams, and you need to correlate it. And that's kind of like correlating across the types, not just correlating on CVEs, but being able to correlate on context. Is it on the same file? Is it in the same code base? Is the container running? Where's the image? Where's the IAC file? So anyway, thank you very much, Rohan. Thanks for watching, everybody. Be safe.
Thank you, and see you next time.
All right. See you next time.